Hello everyone, and great talk earlier from Steve. Really, really interesting. Really enjoyed. But now we are changing tack a little bit with a topic that, as you can imagine, has been covered to death over the past 6 months by literally anyone in industry and outside. But here I want to bring some real-world examples, some stuff that I did myself personally, and that we can also use. I mean, they're taken out of context from the professional setting, kind of simplified, and we can talk about it freely. I'm Matteo. I work at Avanade UK. I lead what we call the software engineering in AMBG group, but at heart, I'm a technologist. I love doing stuff. I love tinkering with stuff, and I'm a Microsoft MVP in DevOps, which means that I've been tinkering with this for almost 17 years. Now, AI very recently, but all the other stuff for a very long time. Now, it's fair to say that software development is the perfect proving ground for Gen AI. And everyone, I'm sure, tried at least once to use Gen AI assistance in software development. If you didn't, you'll see how to do it. But in general, you recognize that this environment, software development being a very small domain from an LLM perspective, it's a handful of words, it's natural language, because yes, code has got different varieties, different syntax and so on, different languages, but the reality is that if you write public, the next logical word would be static or something similar. So for an LLM, that's very easy, and that makes it really, really impressive what you can do with it. And that's why we get to the point where Gen AI tools for developers are super mature. First generation of them, GitHub Copilot, Amazon Q, Windsurf, the main ones, the mainstays, if you like, that we had for the past few years. Reality is that this doesn't stop. This is just the first generation. And we're now moving to a second generation, which is this. Cloud Code, OpenAI Codex, Kiro, coding agents, anti-gravity, and there's going to be more. To the point that I'm not mentioning GitHub Copilot CLI, because it's been released a few days ago. I'm using it already. You will see that in action. And some of the demos that I did are essentially now outdated, and I needed to redo them again for this talk, even if they were designed, I think, in November, end of November, thereabouts. AI moves at breakneck speed. AI is something that changes every single day. Nobody can be called an expert in AI. I wouldn't dare to call myself an expert in AI, because AI today is not going to be the AI in 6 weeks. So with this in mind, we talk about something that's really important. When you have Gen AI augmented developers, and I'm not talking people like myself that run a business, run a function, run a department, coordinate with architecture, stakeholders, development team, engineering managers. So the time that I spend actually coding is very limited, and 99% of the time is outside of what I do professionally. But imagine a Gen AI augmented developer, someone that 6 hours a day is sitting in front of a keyboard, sitting in front of a screen, leveraging Gen AI in their job day in, day out. They need a different mindset and a different developer experience to actually do their jobs. Because as much as DF has transformed, and they moved away from the traditional static, siloed organization that they might have been, from what I heard from Steve, and now they are a very agile organization. Same goes for developers. Developers nowadays, a Gen AI augmented developer nowadays, doesn't pick up pen and paper, start thinking about the process, the workflow, the code that they need to implement, and then they start writing unit tests for it. Yeah, I did TDD. I remember TDD. Start writing unit tests for it. Then, okay, they're all red. I start implementing code. They turn green, and we start opening the PR and so on. If you are a true Gen AI augmented developer, you're probably starting directly with the LLMs, plural. There's an LLM for every time of task. You don't go in and let's say, oh, I'm going to use Claude Opus exclusively for everything that I do. It's going to cost a bomb. It's not worth it. It costs too much. It's too slow because it's a reasoning model. You don't need reasoning for everything, right? So you will find that the way people start nowadays is either using something like this. So, okay, pick up a piece of code, refactor that, do something, think about doing something different, or I want a different type of implementation, or do something for me. Build an API that returns current time, and it needs to support user authentication. This is a very simple request, right? And the first thing that should happen here, given that this is a very bad prompt and a very vague request, is that my LLM or my assistant in general should block me because, oh, look, you're trying to use public code. And you should not use public code in a corporate setting because otherwise there are legal implications, there are problems, reusability, and so on. Eventually you should get something better. Now, the gateway, I call it the gateway to vibe coding. Everybody has heard about vibe coding, right? I'm not even going to ask you to raise your hands. Everybody has heard about it. Well, not everybody, but some are trying to do it, some are trying to criticize it. I would say that the reality, as always, is in the middle. Can you do vibe coding? Absolutely. Should you always be doing vibe coding? Absolutely not. All right? But the gateway to do it right, and that's what we're really interested in. Like, I'm not going to talk to you today about my hobby app that I made over a Sunday, in spare time. I'm talking about how we do this in real organization with clients. How do you bring vibe coding into an enterprise organization? And the gateway is prototyping. Now, enough with the slides. I've got a few more slides. They're all for context, okay? Just to follow a logical thought. But there are several ways nowadays of vibe coding. The most common one is this. Can you see all right? Let me see if I can zoom in a bit. The CLI. You might be using Codex, you might be using Claude, you might be using whatever, okay? But the reality is that what I can do is something like this. And I'm using the GitHub Copilot CLI simply because I'm comfortable with it, okay? But before you ask me, there is absolutely no difference between doing this with GitHub Copilot CLI or Claude Code or OpenAI Codex or any other vertically integrated toolchain. The only difference that there is between all of this and GitHub Copilot is that GitHub Copilot gives you the horizontal integration. You can cherry pick different models, you can cherry pick different things, but it's compatible with Claude Skills, which is now a standard. And it does essentially the same things as Claude Code when you use the CLI. So there are differences, there are nuances, but for all intents and purposes, over here what I want to do is to start thinking about, I want to do something, all right? And that something might be something simple, but if I'm a GenAI augmented developer, again, I don't go and write code right away, because that's not vibe coding. And also, I'm not starting with, please implement this. Doesn't work like that. If you do it in an enterprise environment, you need to do it in a way that gives you the fundamentals right, that gives you something that you can leverage. And over here, you can see an error, well, not an error, a warning message that says no Copilot instructions found. Now, this is because I'm just doing it on the fly to show you what's the 0 to 1 to start with. Real enterprise environments will have multiple layers of coding instructions, and we will see them slightly later on in the session. Coding instructions are instructions for the LLM, instructions for the agents. Use this naming convention, use this structure, make sure that the code is written in a certain way, and so on and so forth. But over here, the first thing that I would do, if I'm starting completely from scratch, and I want to just jot down an idea, like I used to on my notepad, what I'll do is planning. Planning gives me the ability of validating the idea before a single line of code is written. So the most basic example, of course, I want to build a simple tic-tac-toe game in HTML, let's say. Why this? Time. I need something that I can show you in 2 minutes, essentially. Now, as you see, this is something that is the next generation. It's already a second generation type thing. I ask for something, and I'm being challenged. Constructively, but I'm being challenged. I'm being challenged, meaning ask, okay, what do you want to do? Locally with 2 players, with an AI of some sort, and so on. In this case, 2-player locally is fine. And then it continues, and it keeps thinking. And I'm just using Claude Sonnet, you might have noted, because, again, speed and time, right? But over here, once it's ready to start, what it will do is create a folder with a project and some metadata, or I can place it elsewhere, but it's fine. And once it's done, then this will ask me, the CLI should ask me, what do you want to do next? Because the plan is essentially there, all right? So building the plan, it is defining it, and now it's saying, okay, this is what I believe, this is what me, AI, believe I should be doing. Tic-tac-toe self-contained in a single file. There should be 2 players locally, 3x3 grid with some logic, no dependencies, pure HTML, CSS, and JavaScript, because I didn't ask for anything else. Do it in autopilot, enable all permissions, and now it's going to start implementing it. This is a way of building prototypes. This is something that developers today can start doing right away with whatever their tool set, whatever the tool chain, all right? And this works very well getting off the ground. So I've got an idea, I want to try a simple library, I want to try a different type of interaction, a different type of integration. That's my result. Looks all right, I reckon. Yeah, it looks good. Works. Right? Simple, obviously, but it gives you the idea. Can I productize this? Absolutely. I can add telemetry, I can add user authentication, I can add whatever I fancy. That's not the point. The point is that this proves an idea. Now, in an enterprise environment, this is not enough to get started because I can check it in the repo and then what else? All right? So I like to use tools like this. And again, there are several examples. GitHub Spark is my favorite because I saw the product evolving from literally an idea up to product. But I've done a number of things with this, and you can start asking questions like build a compound interest visualizer for the compound interest visualizer. That's fine. It's going to figure it out by itself. And this is going to start building something end to end, but it's also going to give you a lot more. It's going to give you an environment that allows you to see the code, and the code is based off standards again. So React, TypeScript, it uses its own key value storage behind the scenes because this is a prototype. This is not a real application. So you should not be worrying about databases and so on and so forth. You should also not be worrying about anything else hosting these applications. And in the meantime that this goes on, I'll show you another example that I've already built, which has been very helpful because I'm an avid gamer and I am on a quest on purchasing all the video games from my childhood. I'm playing them on a CRT TV that I have in my office with the actual consoles, no emulators, nothing like that, all right? And obviously over time, you start building a sizable collection, which is why I said, rather than using my Excel file that I used for years, I would like to use something that I can actually tinker with and I can use as also as an example. And I started with Copilot Spark. Now, over here, you will find that it takes some time because this has been developed over a few months. And there is quite a lot behind the scenes. We'll see that in a second. But the reality is that this application over here exists as, where is it? Sorry. This application over here exists as a published environment. There you go. So this is the prototype as it is. This prototype started with a very simple, with a prompt. It was a good prompt, this one. What do I want? I want an application that tracks these categories, has got these properties, picks up logos from these places, and so on and so forth. This is a very good prompt. And it gave me, and I can go back in time, it gave me something that was good to start with, which is now loading. And this was the starting point. Now, over time, I added more features. I added the wanted tag, I added the requirement that I wanted at least 3 cards per row, and so on and so forth. If I want to do something and check something myself, I can go to the code. And I can edit the code directly over here. I want to get to the point where I want to test my application. Brilliant. I will deploy it to Spark. And this is just a prototype, all right? But this is React. This is standard programming languages. This is standard runtimes. Nothing fancy, nothing special. It runs in an environment that is self-contained. I've got, if I go back here, I've got theming support. All right. I've got access to my key value storage. Fantastic. Love it. I decided that it's fine. And I can convert this like I would in a real world environment to a real application, because this is not a real application, all right? This is subject to so many limitations, including the fact that it's reliant on GitHub and so on. So what you do, as you would in a real world environment, is to convert your prototype into a repository. This repository sits in your personal account because it's your prototype. If you are in an enterprise organization, you're not using personal repository. Even inside a team, a team construct, a team setup, what you would then do is to fork it into something that is governed, standard. It's got governance on it, compliant, etc. Now, ignore the fact that this is my name and surname. That's my personal GitHub account, MattVSDS. Matteo Emili is my personal organization, like it would be Matteo and Avanade or Accenture or whatever other corporate entity you want. And this is where you start working properly. Because if you make any change, like I did over here, free commits, if you make any change to your prototype, which as you can see is already generated from a Spark template, so it's already a fork of, essentially, you will go and modify the actual Spark. So you will find over here that there are some iterations that I've done where it was manual edits. Those were partly me tinkering with the code and changing a few things in the model, partly me then pushing some commits by mistake and letting builds run by mistake because they were targeting the personal repository rather than, let's say, the corporate one, the team one. Now, this alone is not enough to consider it ready to go, because that's just the starting point. It's an idea, you validated an idea, now that needs to be productized. And that's where vibe coding becomes agentic engineering, all right? So we start from this, and we will see what happens next. And in the meantime, we got our compound interest visualizer, all right? So that was done behind the scenes, it's been running, and there it is, with a extremely bad prompt, right? So it did it on its own, brilliant. But over here, if we continue with our conversation, and we will get to the point of proper engineering, you could ask, but how about agents? Because nowadays, everyone is talking about agents. We're no longer using ChatGPT in the browser. We're no longer doing things manually like caveman 6 months ago. Yeah, that's right. That's absolutely right. And agents will give you speed. Agents will give you two other things that we will see in a moment. But things that you can do with agents is creating a requirement and letting the agent run. And you will get something back from the agent. Agents will give you control. You can scope what the agent does. You can scope what is the focus of one or more agents. You can have agents doing the thinking, as I like to call it. So you pick up a requirement, you break it down into smaller implementation tasks, like you would as a developer working with a product owner, a BA, and so on. Then that could be done with Opus, let's say, or with Gemini 3.1 Pro, or with any other deep thinking model. Once you get your task broken down, you pick up a model that's quicker, but it's still more balanced. I love Sonnet. I can't do anything like, for me, it works perfectly. And you let them implement those tasks inside the requirement. But then you can also attach another agent doing a pull request review. You can add another agent that checks and validates what's been done, because AI is there to accelerate you. As an engineer, evolving towards an AI native role, you are fundamental for the domain knowledge you have, for the business knowledge that you can bring into an application. But code, in the craftsmanship term of code, has been solved, all right? Code quality is super important, and you can control it with, as I said earlier, with coding instructions, but you can have something like this where Copilot does a review of what another agent has done, and you can get a summary, in this case, per file of what's been done. And then you can get the critique from the agent against another agent of what's been done and why it's correct or why it's wrong and why it should be addressed. All of that with CLIs as control surfaces. So, as I said earlier, Copilot CLI, Cloud Code, OpenAI Codex, etc. The vendor lock-in here, realistically, is minimal, because they are all working against what are emerging standards. There's no single head of the race, that is running away in the distance and the others are catching up. Today could be Anthropic, tomorrow is going to be OpenAI again, as it happened a couple of weeks ago. In another few weeks, it's going to be someone else entirely, or it could be, again, Google coming up with a different version of Gemini that is specific for coding. Things change at such a breakneck speed that the best way of keeping things under control is with CLIs. As a developer, your standards are CLIs, and CI/CD pipelines. You don't have to worry about anything else. Plug and play your model, plug and play your platforms even, because as I said earlier, GitHub Copilot, fully compatible with a Claude Skills model, which is a standard, and it also exposes the full Claude and the full OpenAI Codex experience. So realistically, you have to use the one that's most convenient for you. I have no allegiance, realistically, talking about GitHub. Like, I love the way GitHub works. It works very well for me. It works very well for my organization. But, and it happened, I had to go on a Claude project because the client in consulting, I was working in consulting, the client used Anthropic tools almost exclusively. Fine, the transition is almost seamless. A couple of changes in the tools, the commands in the CLIs and so on, but that's about it, all right? And as I said earlier, use Copilot instructions all the time, because these are, again, standard. It's small, admittedly, but this is the first part of a large Copilot instruction file, which talks about the instructions for a very, very simple API. Remember the API that I mentioned earlier, the C# API that was blocked, right? That's what I use as coding instructions to tell any LLM, this is how you work with it, this is how you build it, this is how you run it, this is the structure, those are the contents, and so on and so forth. So this file is, in reality, it's over 150 lines, all right? That tells any agent what to do. Real-world enterprise environment, you will have enterprise-wide rules. Then you will have organizational rules. Every organization might be different. The EDF example, nuclear is different than retail. They're all part of EDF, but they will have different rules. That's how we implement them. And then you will have inside every repository standard instructions that could be customized, extended, depending on the type of project, but you have these instructions that guide every agent. That's how you get enterprise-grade GenAI for developers. Now, you saw how to do it with Copilot CLI, but what you can also see now is that this application here, which is our starting point, this now runs on Azure, in a real Azure environment. It runs in an Azure static web app, with a storage account, with a table storage, acting as database. Nothing from GitHub Spark, all right? I didn't do this manually. As I said, I can pretend to be a developer nowadays after so long in the industry. But the reality of facts is that all I did was using coding agents, okay? Let me pick up the right Visual Studio instance. So back a few months, as you can see here on the right-hand side, I did a number of things with agents. The first one, and the most important one given the type of application, is to migrate to Azure table storage, remove the dependencies from the key value storage system of GitHub Spark, and then make sure that it's documented. I can go back. I can open the whole session here. Let me just go full screen for a second. And I can show you that this is a fairly chunky session, all right? Because this is back and forth with the agent. The agent is running on its own, as you can see. I told the agent, this is an application provided with GitHub Spark. The front end is built. I need to remove the key value storage system and replace it with a table storage. You can find references to the key value system here, this way. All the CRUD operations are currently against that storage system. I need that replaced. Why the reinforcement? This is prompting, right? You have one-shot prompting, you got multi-shot prompting, and so on. But this is reinforcement. And most importantly, remember to use the REST APIs and cores and to document setup and changes. Why is this? Because this simulates best practices and standards inside an organization. If I didn't do that, the agent could have done it its way. But if I do it this way, I'm simulating, this is my standard, you do it this way. It goes on, it does its own thing for a while. And as you can tell, at some point it asked me, after a few requests, shall I continue? Because it's taking quite a while. Obviously, yes, because I understand the type of problem and so on. Summary, all done, documentation, yada, yada, yada. But, hey, I don't want to use a SAS token at this point. I want to try something different. So, okay, fine. I want to use a key And then I thought, no, I don't want that. I'd rather have a SaaS token because it's got an expiration and so on. So I stopped that. But I said, the games are actually not saving. I tested it myself, and the games were not saving. So there was no persistence actually happening. So all right, let me figure it out. It does its thing again. It created a troubleshooting guide for me, and it's still not working. It's not working, it's just in production, because I added that to the web app configuration properties. So make sure that you account for that in the documentation and add Mac specific instructions, because I was using obviously Azure. The vast majority of documentation for Azure is on the Microsoft stack. I moved away, I'm using a Mac, so I want Mac specific instructions. Fine. And then it goes on. And again, the interesting thing here is that once it's done, you have such an amount of good information that it supplements the work that engineers do incredibly well. You can do it from here, and as you can tell, you can do it very easily inside your IDE, or you can do it directly from your repository. Because here I can go in and say agents, and I can say, with the context of this repository, okay, exclusively with this context, I can say, okay, I want to do something. And again, I can't help myself because this world goes at breakneck speed. So I said, okay, implement something from here, all right? Implement something from here, please. The evolution here is such that in the IDE, you're working directly with the agent, back and forth, right? It's chat communication. Here, I asked to implement dark mode for this application. It did. 8 minutes 41 seconds. But it didn't work. And how did I pick it up? You know, it understands the repo, blah, 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 brilliant, okay? Fantastic. Reality is, after all these 8 minutes, it did all the scaffolding right, but I noticed when the agents gives me the evidence of what's been doing, that the evidence shows that it's not working. So, all right, fine. I changed the model here. I was using OpenAI Codex. I changed the model here. Close on 4.6. Both toggles are just showing the lighting. I tested it. Can you implement it right? 6 minutes and 18 seconds later, it does it. It explains me why. It adds documentation. Okay. And, as always, because this is new, it gives me evidence. This is not the environment mind, okay? This is literally just a JPEG file of a screenshot that is taken from the agent running the build and the CI/CD. He runs that, deploys it locally, runs it locally, and shows me, look, I've done it. This is new as of 2 weeks ago, all right? Now, brilliant, okay, fine. You open the pull request now, because this is all done in a pull request. And then I can say, you know what? I can have Copilot code. No, that should not happen. You see, the things break continuously, all right? But you can have Copilot doing reviews. This is because of my organizational account being moved from the licensing of Copilot. It used to be on my personal account. It's now been moved to an Accenture organizations, and all the permissions have not been propagated correctly. So that page exists, but I can't access it because I don't have the same level of permissions elsewhere. Now, this, for example, when I said, oh, Copilot, you know, both toggles are showing the lighting, can implement dark mode, I mentioned Copilot, and that's where you see the emoji here. Obviously, it went away, but you see the emoji of the two eyes looking, because that's what it does. And you can say, okay, fine, I will pick it up, and I can see the session in the PR, and you go back to what I was showing earlier. Now, this is simple, all right? Let's be honest. This is a very simple application. And by the way, I asked it to implement agent, CI/CD and everything, right? I'm not joking when I say that this is, this has been deployed. So this is Copilot running in its own environment. But if I go back to agents, and I want to pick up this one, the last, 20th of Feb, so a few days ago, build and deploy. And if I go over here, let me see if I can pick up real quick the URL, because I want to pick up the URL directly from here. That's Oryx. Yeah, fine. Yes. So It's not like I'm showing you a different environment. This is my collection. This has been actually built and deployed automatically because I asked it CI/CD, infrastructure as code, configuration as code, the whole thing, the whole 9 yards, all right? This, actually, because I've got plans of extending this even further, because as a test bed, it's fantastic. This can also be run as a fully multi-tenant application. It's been developed as such. So if I can pick up the workflow, I can say, okay, run it again. I can say, okay, you can target the different branch, you can redeploy to an existing environment, or you can deploy a different type of environment. This was all done by Copilot. Just prompts, nothing else. That is because it's a simple app, it's a demo. Real world environment, in between prompts, you have engineers validating, extending, building. But the ratio of building versus testing versus prompting varies wildly depending on the level of maturity that you're reaching in a given code base. Now, there's more. Questions, anyone? You've been incredibly quiet. You can interrupt me anytime for questions.
Question.
Go for it.
You vibe-coded the tic-tac-toe
Yeah.
app. If you were to redo the same prompt,
Mm-hmm.
would it result in the same exact thing or slightly different?
Slightly different, but with the tic-tac-toe, explicitly, it's such a generic and over-abused example, the chances are you're going to get 99% the same result all over again. Because it's literally the starting point that everyone uses. It's either that or the note-taking application, the to-do list applications. Everyone uses those two examples. Reason being, Copilot uses models that have been trained on GitHub.com. So you're going to get similar results for very broad-ranging and non-refined use cases.
Even the compound interest one.
So again?
Even the compound interest app.
That's more varied. That's more varied because compound interest can be anything, right? But tic-tac-toe, to-do list, and a couple more, they've been so abused over the past 3 years, that everyone is doing them. There's convergence in the results, all right? But that's due to the models being trained on GitHub.com. If you use your own model hosted in, let's say, AI Foundry, and it's trained on your code base, results are going to be widely different. You might not even get the result, all right? Now, brilliant, we got vibes, right? I'm young, yes. But we need to govern them with reliability because enterprise, right? We're not talking about one-man band churning out releases over releases and broken stuff over broken stuff. The answer is spec-driven development. Here I'm going to ask you, who knows it? Right. How are we doing with time? 8 minutes. So AI is creativity. It's unquestionable. But we can use that to break work down in an enterprise setting from a requirement that is potentially written by humans, which might not be, the Cucumber syntax, to keep it very simple, is not really meant for agents. Agents want something different, right? And spec-driven development with agents will give you the scale you need. Because, you pick up your backlog, you pick your top 50 items, you can spend, let's say, a day, all right, breaking them down and refining them for agents, and then you unleash the fleet of agents. You're going to burn through tokens, obviously, but the results are going to be incredible because you're going to have something like this. I'm not going to run through the whole thing simply because we only have 80 minutes, but I'll give you the flavor, all right? So spec-driven development works off the back of an idea called Specify. Specify is a toolkit. Okay, it's available on GitHub. Everyone is using it nowadays. There are different versions, different permutations of criteria, but the reality is always the same. Let me pick up the right file so I can actually show you how it's broken down. So your tasks, let me see if I can retrieve it because I didn't do it inside here. Okay, let's do it then. Okay. So realistically, I'll go very quickly. You have a concept called constitution. Constitution is your memory. Okay, so the core tenets, the core things that your spec-driven development, agent is going to follow to break down your requirements. It's important because there are things like don't break the Jira references, to name it simple, or use this persona defined as user, super user, administrator, and so on and so forth. Now, off the back of that, you will do a number of things, all right? You will start with a spec. The spec obviously is the specification, and it is something that consumes this template, which everything can be amended, mind, okay? So you can customize it to, and you should, to what the organization needs, but it picks up this and says, okay, those are my fundamental concepts that you need to follow as an agent in order to break down an idea into a plan. So my plan needs to go off the back of a spec, of a specification. How do I validate the specification? By building it. So there's a number of criteria. There's a structure that, again, you can customize. In this case, it's very simple. What's the user journey? Why it's important? How do you validate it independently? So acceptance criteria of your user story. And then what are the scenarios? Cucumber, again, because you can track states, actions, and outcomes. This works because those three parameters are actually deterministic, I should say. If you say, given that I'm a user, when I click a button, I receive a certain message, it's not deterministic, because a button could be anything, it could be anywhere on the screen, but here is going to be an initial high-level view of what's the acceptance scenario, right? Because it will be then broken down subsequently into a plan. The plan is the technology implementation of the spec. So this is where you say, I want JavaScript, I want React, I want ASP.NET Minimal API, I want whatever else, okay? Use this database, use this library, use this, use that. This is the architecture that you should follow, and so on and so forth. So this gives the high-level starting point for the implementation. We're not there yet, though, because the final step is breaking down the implementation design into tangible, workable user stories. And that's work that teams, BAs, product owners, and so on do every single day. As we know, it takes time. And everything is so well crafted, but the reality is that it's a snowflake. You don't have two user stories alike. Even if they are weighted the same, estimated the same, there's always going to be subtle differences. Here, you don't have that problem. So what I did was running this, and my lovely SDD, or my lovely spec kit as it's called, has built a whole set of specs for a simple Azure Verified Module Composer, right? So if you're familiar with Azure Verified Modules, it is a set of infrastructure as code templates that are considered the golden standard by Microsoft, and they're also co-developed by the community, simply put. I wanted to build a very simple idea of sort of an internal development platform type experience where I can compose these modules. So what he did here is building the checklist that it should follow. So those are the core standards that it should follow. The contracts for the APIs. I know I'm scrolling, but I'm not even looking because I know it's long. Then the data model to follow. What is the actual plan that needs to be followed in order to build further user stories down the line? The research that he has done around the initial prompt. So I want to build something, that's composing of infrastructure as code modules, blah, blah, blah. It has done this research before kicking off any steps. And over here, you can tell, because I used Opus, obviously, the research is pretty deep. Then we got the spec, which is the set of user stories, stopping on one, all right? User story 3, review and share composition, has got a certain priority, why it's important, test, acceptance scenarios, edge cases, requirements, functional requirements. This goes on. This is done in minutes, by the way. I'm not showing you the end-to-end because we only have 8 minutes and it takes roughly 10 or 15. But this is what it does behind the scenes, and it gives you as an output. And then has the tasks, which is the super cool thing, because I can say, as I did over here, oh, actually, I had the session open, so I can show you. So that's the original prompt, what I want to build. Then I say, okay, create a plan for the spec. I'm building with ASP.NET minimal APIs for the backend. Choose whatever you want for the front end. I don't care, because I'm not going to maintain it anyway. You see, it's agent maintained. If you need a database, my lovely table storage, because for those use cases, it's very simple. Does its thing. I don't need a constitution, because I'm fine with what you already have. I don't need anything custom. I needed it to get off the ground. It's broken down the plan into tasks, generated over here. And then I can say, all right, crack on with the implementation of the first three phases, so the scaffolding and so on and so forth. Result, I want to show you here. So let me go to another. Yes, compose it. Actually, should it back in and then run. The backend is the naughty one that needs to be started first, and then over here I'll go to the front end and npm run dev. This error is expected because I don't have a real storage account behind the scenes. So it's only using demo data. And if I open this, open with Safari, this is what it has done off the back of that session, off the back of spec-driven development. This works, right? So I can add a virtual machine, can configure it, I can add a virtual network, and I can get my zip file. Next step would be obviously picking up the other user stories, continue to develop it, and so on and so forth. But those are things that we do. I mean, this is obviously developer for developer, internal productivity, and so on. But think about it. This is a little bit more than a simple gain collection tracking system, because this fetches data from GitHub. This does some compute on its side, does normalization, it gives me the zip file, and so on. And obviously, there's going to be more in the future, but that's a pet project of mine on the open source space. I haven't written a single line of code over here. This is just agents, right? And I did that in, I mean, we can have a look. So Codex Max 5.1 has done, let's see if I go timestamps. No, I don't have timestamps, I'm afraid, but I can tell you that this can be done in a matter of an hour, no more. You as a developer, you got your ground nicely laid out so that you can start developing yourself if needed, or continue using agents as much as you like. Questions?